A variable air volume (VAV) system in a commercial medical office building must be designed to ensure comfort, air quality, and energy efficiency while complying with standards for healthcare facilities. Below is a detailed sequence of operation that includes various key components such as economizer mode, energy recovery ventilators (ERVs), power exhaust, and morning warm-up, along with energy-efficient control strategies. 1. System overview. The system consists of VAV air handling units (AHUs), terminal VAV boxes with reheat coils, electric or hot water, economizer mode for free cooling, energy recovery ventilators (ERVs) for energy efficiency, power exhaust fans to manage building pressure, morning warm-up mode to precondition the space before occupancy, building management system (BMS) for automated control and monitoring. 2. Modes of operation. The VAV system will operate in different modes depending on occupancy, time of day, outdoor air conditions, and indoor set points. 2.1 Morning warm-up mode, pre-occupancy. Objective: raise the building temperature to the heating set point before occupancy begins. The system will start in heating mode, with all VAV terminal boxes fully open to allow maximum airflow. Heating coils in VAV boxes. The reheat coils in terminal units will be enabled to heat individual zones. The AHU supply fan will operate at 100% airflow, overriding VAV damper modulations to ensure that heated air reaches all spaces quickly. Once the zone temperatures approach the occupied heating set point, VAV dampers will begin to modulate to their normal control position based on local demand, and the system will transition to occupied mode. 2.2 Occupied mode. VAV boxes. Each VAV box modulates airflow based on the demand from the space it serves. Each VAV box has a minimum and maximum flow setting, modulating to maintain the temperature set point in its zone. Reheat control. In zones that require additional heating, reheat coils, electric or hot water, will be activated. The system will prioritize minimizing reheating, with terminal units receiving air at minimum flow set points when possible. AHU fan speed. The supply fan in the AHU is controlled by a variable frequency drive (VFD) and modulates to maintain static pressure set points in the main duct. As VAV boxes close, the fan slows down, saving energy. Supply air temperature reset. The BMS adjusts the AHU discharge air temperature based on the highest cooling demand. This minimizes overcooling and reheating, improving energy efficiency. 2.3 Economizer mode, free cooling. When activated, economizer mode is activated when outdoor conditions are suitable for free cooling, e.g., outdoor temperature and enthalpy are below predefined limits, such as 65 degrees Fahrenheit and low humidity. Operation. The AHU modulates outdoor air dampers to allow 100% outside air into the building, reducing the need for mechanical cooling. Control. The supply air temperature is maintained by modulating the economizer dampers. The cooling coil is disabled during economizer mode unless outdoor air alone cannot maintain the desired temperature, in which case mechanical cooling is used in conjunction with economizer mode. Shut off. Economizer mode will shut off if the outdoor air conditions are unsuitable, e.g., high temperature, high humidity. 2.4 Cooling mode, mechanical cooling. When activated, if the indoor space temperature exceeds the cooling set point and outdoor conditions are not suitable for economizer mode, the system switches to mechanical cooling. Operation. The AHU modulates the cooling coil valve to maintain the supply air temperature set point. VAV boxes modulate their dampers to meet individual zone cooling requirements. Fan control. The supply fan speed is modulated to maintain static pressure as VAV box dampers modulate to control airflow. ERV operation. Energy recovery ventilators (ERVs) will operate to recover cooling energy from exhaust air, reducing the cooling load on the AHU. 2.5 Heating mode. When activated, if the space temperature falls below the heating set point during occupied hours. Operation. The heating coil in the AHU will modulate to maintain the supply air temperature, and terminal VAV boxes will modulate their reheat coils as needed to maintain individual zone set points. Fan control. The fan continues to operate based on demand, with the VFD modulating speed to meet the system's static pressure set point. ERV operation. ERVs recover heat from the exhaust air, preconditioning the outdoor air before it enters the AHU to reduce heating loads. 2.6 Energy recovery ventilators, ERVs. Operation. ERVs operate continuously when outdoor air intake is above the minimum required for ventilation. They transfer energy, heat or cooling, between the exhaust air and the incoming outdoor air, improving energy efficiency by reducing the heating or cooling load on the AHU. Bypass. During economizer mode, the ERVs may enter bypass mode to prevent unnecessary heat exchange when 100% outdoor air is used. 2.7 Power exhaust fans. Purpose. Power exhaust fans are used to control building pressure, particularly when large quantities of outside air are introduced during economizer mode or when the building is heavily ventilated. Operation. The power exhaust system is activated when the building pressure exceeds a set point, e.g., due to high outdoor air intake. The fans modulate to relieve excess pressure by exhausting air directly to the outside. 2.8 Unoccupied mode. VAV boxes. During unoccupied hours, VAV boxes are set to minimum flow or fully closed to reduce energy consumption. AHU. The AHU operates based on a night setback temperature, e.g., 60 degrees Fahrenheit for heating or 85 degrees Fahrenheit for cooling. The system will only turn on if the space temperature exceeds these limits. ERVs are disabled unless required for minimum ventilation. 2.9 Demand Control Ventilation, DCV. CO2 sensors. CO2 sensors in densely occupied areas, e.g., waiting rooms, adjust ventilation rates based on occupancy. If CO2 levels exceed a threshold, e.g., 800 ppm, the AHU increases the outdoor air intake to improve air quality. Integration with VAV. As occupancy changes, the VAV dampers adjust airflow to maintain the desired ventilation rates without overventilating, further optimizing energy use. 3. Energy-efficient strategies. Supply air temperature reset. Adjust the discharge air temperature based on zone demand to minimize cooling and reheating. Fan speed control. VFD modulate the fan speed to maintain static pressure, reducing energy use as the load decreases. Night setback. During unoccupied times, reduce energy consumption by allowing the building to drift to lower or higher set points. Economizer mode. Maximize the use of outdoor air for free cooling when conditions permit. ERVs use energy recovery to reduce the demand on mechanical systems by capturing energy from exhaust air. This sequence ensures that the VAV system operates efficiently while maintaining comfort, indoor air quality, and energy performance in a commercial medical office building.